Hi, I'm Phil, and today I'm going to look at the kids IoT network. And IoT stands for the Internet of Things. So if you look at my mind map here, you can see I'm going to use this in both STEM education in STEM clubs and also in makers clubs. This provides a very simple way of using the internet for the Internet of Things. I've done a few projects on this. What I'm going to focus on today is this project. So you can see the arrangement. I'm going to use microbit as the computer. It will collect data on the air temperature, humidity, and pressure, and also the fine particles, the PM2.5 dust particles in the air. And it uses Wi-Fi to connect directly to my mobile phone and then onto the kids' IoT website. And for the temperature, pressure, and humidity, I'm using a BME280. And here you can see the hardware that I'm using for the PM2.5 measurements. So the objective, to demonstrate the transmitting weather data to the cloud. That is air temperature, humidity, pressure, PM2.5, and I'll retransmit that data every hour. And this has been prepared as a demo for the Parramatta Council Library. And I'm going to use my mobile phone there as a hotspot. So let's have a look at the hardware in detail. I'm going to use a microbit, and it happens to be version 2. And I'm also going to connect the microbit to a Nezha microbit adapter. So on the right, we have digital and analog ports, and on the left, we have the I2C ports. So those I2C, all of these ports are connected to PlanetX devices. And the first one on the top is a Wi-Fi module, an OLED display, and the BME280, and finally the PM2.5 sensor. So the design, we're going to use a cloud service, which is the kids IoT, and we're going to also show the results on the OLED display. So the connection looks like this. So we've got a Windows PC that does the programming, and also in this case is providing some power, but most of the power is in the internal battery of the Nezha microbit adapter. And this is the kids IoT network. Software-wise, you can have a look at the code. Not that complex, and we'll have a look at the demonstration now. Just before that, we'll just show you the references, and you can go to the website of the Kids IoT Network, or go to Elecfreaks if you're interested in the Nezha Inventors Kit, which some of the modules are based on, but I'm using additional PlanetX modules from them. And we'll have a look now at the website. So here we are. We're measuring on topic 1, temperature, topic 2, humidity and pressure, and on topic 5, the PM2.5. So we can have a look at the details now of temperature. So you can see I've been collecting these every minute, and hasn't changed much. The temperature in my study is 17 degrees. We'll go back. We can have a look at the humidity. Got a humidity that's varying between 50 and 53, up to 56. And pressure. So we can see the pressure is in hectopascals, 1014. And finally, we can have a look at the PM2.5. That's actually going up and down, not by much. So there's not many dust particles, but it is varying a little bit. And that's the demonstration of the kids' IoT network. This is the hardware for the kids' IoT network demonstration, and it's all based on using a microbit computer on the right here. And that fits into a Nezha microbit adapter. And we've got on port 2, we're connecting to the dust particle sensor, which is a PM2.5 sensor. And on port 1, we've connected to a Wi-Fi. So here's our Wi-Fi on port 1, and we've got two we've got two devices on our I2C. So our I2C connections are in blue here, and the first one is our OLED display. So you can see it's showing temperature, humidity, pressure, and the PM2.5 reading. And we're also measuring the air temperature with a BME280